Hello and welcome to Google Cloud Security. I'm Brian Ray, a lead software engineer on the Google Unified Security team, and today I'm here to share an exciting new open source project we are releasing on GitHub to support MCP, or Model Context Protocol, allowing you to use any supported large language model client alongside your Google Cloud Security products, including Google SecOps, both SIEM and SOAR, Google Threat Intelligence, and Security Command Center. Today we'll cover what is MCP, the architecture of how the server and the client interact, how to install and run our MCP server examples in a client, and finally some security use case examples. So what is MCP? Model Context Protocol is a standard way that AI clients can communicate with servers to use tools and other resources. And really, a client is simply an application that is doing some job, and the most common clients today are chat interfaces. Usually desktop software, whether a standalone large language model chat interface or an integrated development environment with an AI extension like Cline or Code. A client could also be your own custom-built application, like a script or an entire security application. And before MCP, if you wanted your client to have access to a tool, for example, a web search or a RAG database lookup, you had to code the tool use directly into your client, which could make authentication and reuse more difficult. So by moving tools to a separate server application, the MCP server can be an abstraction that any client can use. And in this example, these tools may connect to a third-party API, like the Google SecOps API. The authentication and connection can be maintained in the server without exposing credentials to the client. And the client and MCP server can both run locally on the same machine, which is what we'll demonstrate here today. Or the client and MCP server could be remote from each other, either local to local or even cloud to cloud. And so for today's demo, I'm going to configure Visual Studio Code to use the Cline extension. And in Cline, I'm going to configure 3 MCP servers that you see here, which are SecOps SIEM, SOAR, and Google Threat Intelligence. Each one has its own unique configuration because the authentication services for each API is different. Then Cline will actually run the Python code for each server in its own container and communicate with that service via the MCP protocol here on my local machine. And then each of those servers will connect to their API from my machine to the cloud. All right, to start, we'll visit the repo on GitHub. And here we will grab the configuration for pip. You'll notice that we have both a UV example, which would require you installing and managing UV, which is a really awesome package manager for Python, or you can use a more traditional pip-like install, which is what I'm going to do here. So I'm going to copy this, and then I'm going to head over to Visual Studio Code. And you can see here in extensions, I already installed Cline, and inside of the Cline settings, I have selected the Google Gemini API provider, given it my API key, and selected our new Gemini 2.5 Pro preview model. I'll click the MCP server, which is these 3 stacks here, go over here to installed, and you can see that I have no MCP servers installed. I'm going to click configure MCP servers, which is going to open up the Cline MCP settings JSON file. I'm going to paste the configuration from the repo here, and then I'm going to go back over to GitHub and grab the command to actually clone our repo. Back here, I'm just going to clone the repo. I'm going to go into the repo and get the local directory, which is here. I'll copy that to my clipboard, and then throughout, I'll need to update the path to the actual code. You'll notice that I have to include the route to each sub-server in here as well. Okay, and then in each server, so I have the SecOps server here. Here I'll need to configure the customer ID, project ID, and region. In the GTI, all I will need to do is provide my VT API key, which I can get from the GTI UI directly. And in SOAR, I'll need the SOAR URL and SOAR API key, which I can get from those. All right, what I'm going to do is I'm going to close this, and in a window you can't see, I'm going to paste my actual credentials, and you can see that the MCP servers are updating. And they'll be starting up, and voila, you can see I have 3 MCP servers running over here in Cline. You can expand each one here in Cline and see the tools available. So for SecOps, I can search security events, get security alerts, look up entities, list security rules, get IOC matches, and then get threat intel, which is access to the Gemini model that's directly inside of the SecOps UI. GTI similarly has 23 different tools that correspond to different ways of getting IOC or other threat report information out of GTI. And then in SOAR, you'll notice I've got a lot of tools, and that's because I've included the integration for several integrations here, CrowdStrike, Okta, and there's several dozen integrations available in the repo that you can add. All right. The last thing I need to do before I can actually use the SecOps integration is do gcloud auth login. And what this does is it runs the gcloud CLI, which I would need to have installed on this machine, and creates an application default credential session with my user so that I can directly interact with the SecOps API without having to manage any separate credentials. But I've already done that, and so I'm not going to do that here. And now when I go over to Cline, I can do things like find one IOC match from the last 24 hours and research it in GTI. The model is going to take my prompt, select the appropriate tool, and say, hey, Cline wants to use the tool on SecOps for get IOC matches. When I click auto approve here, the next time that tool is called, I won't have to discreetly approve it. And this is a nice security measure to make sure that you understand what this LLM is doing. And sure enough, we actually didn't find any. Yeah, let's search for longer. So it has a question. It didn't find any in the last 24 hours. Let's look for 7 days. Ah, we found one. It looks like a test domain. So it's not going to be very interesting, but you can see it's going out to GTI and getting a report on the domain. And then it's basically saying, okay, here's information about the domain, first seen, last seen, and it says it appears to be a test domain and not associated with any malicious activity, which is great. Okay, let's do something a little bit more complicated. Let's say search for DNS lookup events from the host James Brown PC in the last 24 hours. And here, SecOps will use actually a natural language search to query for DNS lookup events from host James Brown PC, convert that to a YARA-L2 query, and then give me back UDM events that are associated with that search. I have to approve this. That ran, I got back the events. It's giving me the events in a JSON form. And we could do something like what can GTI tell us about the domains accessed? Okay. 12 security vendors have classified this domain as malicious. It's associated with this car wash malware, and we could do stuff from there. Finally, I wanted to demo a pretty complicated use case and then let it run in the background a little bit. Start a new chat. And here I'm going to take 5 cases, examine the underlying entities, ask the AI to group them together and do some additional research, and then finally create a report about the findings. And this is going to hit all three of our surfaces, starting with the SOAR to look at cases. Okay, so the SOAR case list cases API was used first. And you can see that it's coming along. Okay, there's 5 cases. Here's the case IDs. And it's going to continue to run. And I've run this before, and it has to go for about 3 or 4 minutes until it's had a chance to do all of the different API requests and look up all of the information that it needs. And so I've saved the report from last time, and so you can see that it was able to create a markdown report grouping the cases like we asked for, and then does a detailed analysis of each case along with the display name, alert, information, recommendations. So a really powerful way of doing some automated analysis just by enabling the MCP server right out of the box. And that's going to continue to run. But I hope that you've enjoyed my quick demo of how to use our MCP servers. I hope you'll head over to GitHub, install them, and try them out on your own. Let us know how it goes. Thanks.